Hello, and welcome to this alumni edition of Eyes on Earth. I'm Sherry Levesey, your host for this episode. For its 50th anniversary celebration in August, EROS made a special effort to invite former employees to the events, highlighting their importance to the center with a stage dedicated to sharing their perspectives. This podcast, like the previous one, brings together excerpts from their talks, as well as impromptu interviews. Today, we'll listen as alumni and others talk about the science and technology that made the EROS mission possible. But the podcast also features the worldwide outlook and benefits to society from the era of Earth observation that began with Landsat 1's launch. To begin, we'll listen to a clip from a 2008 interview with Virginia Norwood and John Denoyer that was shared with the alumni stage audience. Norwood, known as the mother of Landsat for her work on the multispectral scanner that proved to be such a success on Landsat 1, or EROS 1, died on March 26 this year at the age of 96. John Denoyer was the first director of the EROS program, operating from the Washington, D.C. office. He died in 2016.
So to propose a scanner for this met with quite a bit of skepticism. And we got, as you may know, we had quite a few stages in the scanner itself. Originally, we were going to do a sinusoidal motion and then have to put up with the variability that entailed. And then we had the sawtooth idea. And to simplify that as much as possible, we decided to bang the mirror back and forth so that between bangs, the velocity, the angular velocity would be constant, and then it would return. And we couldn't use the return at that time for quite a few reasons, so we used the return intervals for calibration lamps, and later on they got the bright idea of looking at the sun once in orbit, so that stabilized the lamp calibrators. And we were able, because the detectors were getting better and all of that, we were able to eke out the signal to noise we needed. Well, we thought that we could probably have a spacecraft that could lift the thematic mapper. And then as time grew, as the spacecraft was looked into more and more, they were sharing a lot of other sensors at that time too. And so we were limited to 60 pounds. And that's for the scanner itself and the data processing. And so that just meant that we had to go back to a 9-inch aperture. And then you didn't have enough collection to support any finer cuts on the spectral bands. Mm-hmm. The users, of course, had been accustomed to something that looked like a spectrometer. It was so fine-grained. And so we had to force them into accepting the 4 pretty broad bands. And when they thought about it more and more, they said, yeah, I think that would be useful to us. So it was a compromise on mass, I'd say, primarily.
Okay. It was a compromise on mass for several reasons. The first Landsat also carried the return beam Vidicons, and the reason for carrying that, they were a rather heavy item themselves.
And there were 3 of them.
There were 3 of them. The reason for having them was that we were sure they would have geometric fidelity, and we were not sure that the MSS would really have map quality, but geometric fidelity. So,
oh, ye of little faith.
It was. I'll get to that in a moment. But it turned out that the MSS did have very good geometric fidelity, and also it was possible to register the different colors in the pixel, different bands in the pixels for each pixel, where you couldn't do that with the return beam Vidicon. And the return beam Vidicon had reticules on it and for registering, and so it was quite a different thing. There was a lot of controversy about which was going to be better before the launch, and I can't help and remember Bill Pecora at one of the congressional hearings was asked which he preferred, the return beam Vidicons or the multispectral scanner. He sat back and stretched a little bit and said, well, it's like beer. There's good beer and there's better beer, but there's no bad beer.
I never heard that.
I'll drink to that.
Very good.
So, Virginia, another aspect, and one of the differences between the RBV and the MSS was that RBV was analog and MSS was digital, which was cutting edge. I mean, we hadn't found a digital scanner. Was it the very nature of the fact that it was a scanner that it needed to be digital, or can you speak to that aspect?
No, it was just that was the easier way to keep the pixels apart.
Okay.
And also...
And put them back together again.
And put them back.
The International Remote Sensing Workshops introduced a worldwide audience to the value of Landsat imagery. Ron Beck, who worked in communications for EROS for decades, shares a few stories of those training sessions, both in South Dakota and abroad.
Probably the best time I had professionally was working in the international program. We set up international training. Watkins and Landis set it up, and Don Lauer and Gene Thorley, and we would offer twice a year training courses for the international scientists. They would come from other countries. The other countries paid their tuition, paid their expenses, and they were here in Sioux Falls for about a month. That was an important part. We did training for roughly 850 scientists from over 100 countries. So we spread the word about the value of remote sensing, and that proved to be critical. Mostly satellite data, because the foreign scientists typically didn't have access to aerial photography, even in their own countries. So this was important that we preached ERTS or Landsat data to them, and we'd spend a week going over the principles and applications and exercises and so on in the classroom. And that was important that we do that. Workshops in Sioux Falls included a weekly field trip, because it was our intention, and the scientists and the educators, two of whom are here, Dr. Drager and Don Orr, said, we're not going to just teach in the classroom. We're going to go out and field check things, because that's what scientists do. South Dakota was a perfect test case because eastern South Dakota, glaciated deposits, western South Dakota, deposits from ancient seabeds, and then the Black Hills and the Badlands, near arid environment in the Badlands, and then the mountainous region of the Black Hills. We could touch on 4 major geologic structures in our training, and that worked well for the students. We had volunteers in the community who would host dinners for the international students so they could learn more about other countries, and the other countries could learn more about life in Sioux Falls. And as a byproduct, a large portion of the Sioux Falls community learned more about what we do out here. The real gold mine, though, in my mind, was what we did in African states, and are still doing in African states, where we applied the technology to various resource management problems in the African countries. And Don Moore and Gray Tappan led the charge on that one. Why do this? Teach people to independently protect their natural resources. And that was our objective. Recently, they've done land cover studies, locust control studies, the expansion of the Sahel region. What was significant about the international training, in my mind, was we brought the attention of Landsat to the global science community and the value of global Earth observations. Instead of an isolated training program out of Sioux Falls, we expanded it to a global system, and many countries have their own satellites up subsequently to that, to doing exactly the same thing we're doing.
Later, in an interview standing outside in the wind, Beck gave more detail about a particularly eventful training trip abroad, a visit to Iran in 1978.
The Iranians took us out for dinner, and they said, at the end of it, they said, Ron, where do you want to go? And I said, I don't want to go to the Hilton Hotel. I want to go to an Iranian restaurant. took us to a place where in a corner there was a guy weaving rugs, which were very important to Iran's economy. Had a nice dinner, fabulous, strictly Iranian food. Laura and I got back to the hotel. Next morning, we were going to fly out to Greece, meet our wives in Athens. I picked up the Iranian newspaper. That restaurant had been blown up. We missed it by 24 hours.
That just makes your heart race here.
And of course we lost all touch with our counterparts in Iran shortly after that because they didn't dare communicate with Americans.
In its 5 decades, EROS has frequently provided imagery and data to help with disaster response. Ron Risty, who started at EROS in 1973, was disaster response coordinator during part of his 40-plus year career at the center. At the anniversary event, he talked about several of those historic moments, starting with the nuclear disaster in Chernobyl.
I remember the very first activity that I got involved with emergency operations, and it was the Chernobyl nuclear accident. And there was an individual that was here from the CIA, and he happened to be here visiting the center that day, and he got a telephone call. And, of course, he had to go take it in the skiff, and at that time we didn't have a skiff, so he just went into a closed door. And it found out that the Chernobyl accident, the reactor number 4 had been blown up. And so it turned out how lucky we were that the Landsat program satellite went over that particular day and was able to capture the image of the shutdown that they had turned it off. So on that following Friday, KELOLAND News, Al Watkins contacted KELOLAND News. They backed up the white truck to the building out here. And, of course, the Soviet Union at the time declined that there was any type of a nuclear reactor that had gone off. But when we were able to show the picture, Al Watkins to Dan Rather on CBS News at 5 o'clock in the afternoon, it was pretty obvious that it had all been shut down. SAS project, which was enormous, that happened, in the spring of 1993 and lasted until the fall of 93. And now, which is the main conference room, we brought in, I think there was like seven different federal agencies. There's like 20 different people that came from around the country. And they were here during that time period. And we supported the SAS project, which was the great flood of the Mississippi River, everything south of Sioux City, all the way down through Missouri River and all the way through the St. Louis confines down to the Mississippi River. And I remember having the opportunity to go down. We got on a barge in St. Louis and went downriver about 20 miles. And we got out and walked up the bank, and they had shovels with them, and they were shoveling at least 6 feet down, and we never got to the bottom of the sand that was washed up on the shore of the agricultural land. And so later on, that's next spring, I was flying down to New Orleans for a presentation, and we flew over St. Louis and that land that the farmers were concerned about because the federal government didn't do anything with the sand because it stretched for miles. And so the farmers, what they did is they windrowed the sand, and the sand would be 20 feet high, and it would be just as long as you could see as you're flying over. And then they were planting their crops in between the windrow of the sand piles that they had taken up off the land. And that's how they were able to at least be able to plant their crops. And of course, we all remember what happened on 9/11. I, myself, and a gal by the name of Brenda Jones had TVs in our offices, and were able to monitor daily activities, what were going on around the world for military support and also emergency operations. And so on that particular day, I usually came into work every morning before 7. And I turned my TV on, and next thing I know, I saw the planes hit in New York. And then it was Washington, D.C. It didn't take long before RJ we knew what was going to happen, called and said up to my office, and this facility was closed because of the federal facility. Myself and a few other people were required to stay here, and we were working directly with people in New York. Later on that night, I got a telephone call from the governor of New York and said he needed a classified database up and running. By tomorrow morning, I need to have imagery that you have and put out there. And then they were collecting imagery as well. And so I had to call people in the computer lab and had some of those people come out. And we had a classified database up and running the next morning. And that was just one of the many examples that we did in support of the 9/11 activities. Katrina, of course, was the big one. We all know what happened there. And the science department particularly were working and supporting, flood inundation maps, how much damage was actually physically done. We worked with FEMA. We worked with the people, in particular the first responders in New Orleans. People were trying to figure out how they can get rescued from their homes when they were in the upper part of their two-story and didn't have address. You couldn't contact, no phones. And so what happened is that these people indicated that we can put their house number on top of the roof. And so they'd go up and paint it on top of their roof or put letters up there so they knew exactly where you were at. And so we were able to collect with drones. We were able to collect with satellite data, different ICONUS and other types of satellite data, and be able to pass that information on to first responders, particularly in New Orleans. Of course, we supported Afghanistan. You're well aware of that. Before our troops went into either Iraq or Afghanistan, we mapped all those countries using Landsat data and sent those maps off to our troops. We did a lot of support by doing activities that were, I guess we had to worry about flooding as they were concerned about the Tigris River. If they blew the dam up, how much water would be concerned. Our troops would be in harm's way, as we found out with the scientists measuring the amount of water behind the dam, that if they did blow the dam up, the water would only be about 6 inches deep by the time of where our troops were at. So there was no big concern there. I had an opportunity. I worked a lot with the Marine Intel, supporting their operations, SOCOM. Again, this is all in support of Wayne Rohde and the military operations. But the other thing they were doing, which I did not know at the time, is that they were putting antennas to receive Landsat data on top of the Humvees. And that was the first time that I'm aware of that outside of EROS Data Center and other collections of Landsat data, but they were collecting Landsat data in the desert off of the Humvees.
Jeff Eidenschink wore many hats during his tenure at EROS, including Fire Science Team Coordinator and Acting Director. His talk on the alumni stage centered on the Advanced Very High Resolution Radiometer antenna, which was housed at EROS from the 1980s through 2017. Data from the AVHRR spurred new directions in land cover research.
Speak a little bit about the Global 1 Kilometer Project, the AVHR project. Many of you know it was near and dear to my heart. So was AVHRR. We started way back in the 80s, way back, and proved the concept in the northern Great Plains and grassland fire danger. Then we moved to the western U.S. And included forest fire danger, worked with people at the Missoula Fire Lab a lot. Then we did the whole U.S. We were doing China. We were doing Alaska. Well, we'd do just about any place a three-letter agency would tell us to do it. And I think that might be the June image 1992, which made it the first global image that we ever completed. And it demonstrated a couple things. Internally at EROS, demonstrated our imagination, our dedication, and intellect, a lot of things to be able to pull this off throughout the center. To the rest of the community, the remote sensing community, here in the United States, globally, we were able to prove that we could do this. If you think about it, it was conterminous US was used for land cover mapping. that led to the global land cover mapping, which Jess and Tom Loveland and Brad Reed and Don Olin and other people all did. And look how important that is. And agribusiness and fire, we still do fire every week. You can look out on the web and you can see fire danger in the United States. And it all stems from the work here and the work we did with the Conterminous US before that. And so, it pleases me that everything we didn't just do for show. It was used. It was used throughout the world.
Dr. Bruce Millett, Principal Investigator for South Dakota View and a professor at South Dakota State University, talked about using Landsat data to research the prairie pothole region.
Some work with the prairie pothole region. This is kind of like in the central flyway for all the waterfowl, for example, that we have flying through there. And I have a graduate student, Madison, who's sitting in the back there. And she's working on these two projects, and her master's thesis will be on using Landsat, and then we'll be looking at surface water, and we're going to be looking at the trends over time, trying to find some hot spots and cold spots out there, looking at climate and seeing where certain portions of the prairie pothole region may be increasing in surface water and other areas that may be decreasing. And this was kind of spawned off with some of my research that I initially had with Carter Johnson at SDSU, and my first limnology class that I had with Steve Chips, standing there in the back.
Dave Greenlee started at the Data Analysis Lab, or DAL, in 1974. His specialty was Geographic Information Systems, or GIS, and like many at EROS, he became involved with many different projects. At the 50th festivities, he focused on how the internet became a platform to share data.
You can remember what happened in about 95. We were starting to go through this, try to figure out what EROS was going to do with this thing called the internet. And when we had, and Bill, you can probably relate to the notion that we were told that we were only to charge the marginal cost of reproduction. And then the internet sort of changed everything, because it was cheaper for us to hang things out there for people and say, anybody can come and get it. It's open. Than it would be for us to take a credit card, make a product, and make the custom product. So that changed for me. That changed a lot of things, because when I got involved with Katrina or the Yellowstone fire of '88, we didn't really worry about. We still had Don Despain from the Park Service who wanted us to do this and that and this and that. But when we did that, we just hung it out there. We just and over the years, it got easier and easier for us to put big data sets out there. And one of the things that happened during the Great Flood, which is the SAS team, is we had like a third of the country that was in our basin database. The floods were the lower half of the Missouri River and the upper 2/3 or so of the Mississippi River. And so the basin, if you can imagine what the basin for that is, we built a database, that had about a third of the Conterminous US in there. And at the same time, we were working with some new technology called the Spatial Database Engine. And they were trying to figure out how to do raster data with the Spatial Database Engine, and they could do vector. So we just started using SDE, which was Oracle and some ArcInfo kind of software. We would hang the kind of stuff we've been working on smallish kind of things out there as very kind of largest things. For me, it came together with what we called the Seamless server, and the Seamless server eventually was served up the topography, like the NED and the stuff derived from NED, and also Jay's the GeoWall and GloVis, the global visualization stuff. People had these good ideas, and some of them came out like this. They'd say, well, we've done a third of the area, and we've got the technology, we've got a little extra disk space. When I go home at night, I'll just turn the job loose, and we'll crank out another little hunk of it. And so that's the way some of these databases got built, and NED was an example of that. So because they had funded projects to do some of these things, but mostly it was like, I would say, ordinary people who just had picked up on this idea, this dream, and then eventually it just became something big.
Daryl Napton, Professor Emeritus of Geography and Geospatial Sciences at South Dakota State University, was a visiting scientist at EROS from 1999 through 2011. His research focus was on land change for the protection of ecosystems.
I worked with the Land Cover Trends Project, looked at 48 conterminous states and land cover changes from the 1970s through 2000. And as I said, we looked at the whole country, and in terms of favorite memories, one of them is we did field trips in all of the nation, 83 ecoregions, to calibrate if what's changed since the last image was taken, and was the last image and the interpretation of it what we were seeing on the ground.
Jim Irons and Curtis Woodcock, who collaborated on the Landsat science team, both traveled to Sioux Falls for the anniversary event. I'll let them introduce each other.
Well, let me introduce my distinguished colleague here. This is Curtis Woodcock. He is a professor at Boston University, and he has served as the leader of the last three, Landsat science teams. So he has been very engaged with EROS for many years. Was a close colleague of Tom Loveland's. You did a sabbatical here, right?
I spent a sabbatical coming to EROS on a regular basis, trying to help start the national LC-MAP, the Land Change Monitoring and Assessment Program. Let me introduce Dr. James Irons from NASA, who served as the Landsat 8 project scientist. And so he helped shepherd Landsat 8 through the process to getting launched. He was also sort of the NASA representative to the science team for the first two terms, at least, of the Landsat science team.
EROS's contributions and impact on our ability to observe and understand how the Earth works has been profound. The biggest event in the last 50 years, in my mind, was what I considered a politically brave decision to release the data to no cost to people who requested it, which was made in 2008, and basically revolutionized the application and the use of the data for science and societal benefits. The example set by EROS was followed by the European Space Agency in their Copernicus program, and they weren't intending to provide their data for free until EROS set that example. So, and it was a big, hard, somewhat painful change here at EROS to go that direction, and yet they made it. And then also EROS has kept up and embraced other important parts of the Landsat program, like calibration and keeping the system calibrated, and advancing the level of data products that are available from Landsat and other systems, and all of that has been very important. But all of it was made possible by this decision to make the data available at no cost.
EROS has provided the gold standard for collecting, archiving, and distributing top quality satellite data that has been the shining light on the hill for the rest of the world.
Thank you to all the alumni who offered their perspectives on the 5 decades of EROS history and people. And thank you to the listeners. Check out our EROS Facebook and Twitter pages to watch for our newest episodes. And you can also subscribe to us on Apple Podcasts. This podcast
is a product of the U.S. Geological Survey, Department of Interior.